Start our next proof here. We are given that line AP, and we're not told this, is parallel to, we need to write that in if that's missing, ln, and we're told that PR equals NR. Our goal here is to prove that PA, the length of PA, is equal to the length of NL. So let's make sure that PA is equal to NL. Now let's go through our given information, make sure our picture is properly marked up. We are told that AP and LN are parallel. So we can see our little marks here, our little parallel marks. Those are already written on there. We're also told that PR equals NR. So we can mark that on there right there again. Now our goal is to prove that these two side lengths are the same. Whenever you're asked to find either equal angles or equal sides, a lot of times the easiest way to do that is to first prove triangles congruent, because you only need 3 of the 6 pieces of information. Then by CPCTC you get any other piece of information you might need. So let's start out by saying how can we get these two triangles on either side, these entire triangles, to be congruent to one another? Because if we can get those entire triangles congruent, we can get the sides as well. I see that I have vertical angles in the middle, so that's something that I could use. So I'm going to just mark those in a different color so I remember I still have to have a rule for that in my proof, but that's information I could get. And then I would have an angle and a side, so then I would just need another angle. If I could get these angles down here, these corner angles, then I would have angle, side, angle, angle, side, angle. Since I'm given that these are parallel, I believe I can get these corner angles by alternate interior angles, because these are the parallel lines coming across. This is our transversal. So by alternate interior, I can say that those angles are going to be equal to each other. So that's going to be my plan. Then I would have angle, side, angle. So I'm going to have angle, side, angle, and then with CPCTC I can break apart the red triangle and the purple triangle and get just this side being equal to each other. So let's go ahead and walk through that more formally now. Start out with our given, and we write exactly what we're given, and we write everything that we're given. So AP is parallel to LN. We also say that PR is equal to NR. Next thing that we did is we jumped to our vertical angle. So we're going to say that angle P, and I got too much on here to read it. So angle PRA, we're going to use 3-letter names here because we have 2 angle R's, is equal to angle NRL. Always use your angle signs. Angle NRL. And the reason we got that again was vertical angles. Next one is those corner angles that we got here, the P and the N. So we're going to say angle P equals angle N. And I can use 1-letter names because there's no other angles there, so that's clear what I'm getting. And we said we got that by alternate interior. So parallel implies alternate interior angles. So now we have all the pieces we need. We have the angle, the side, and the angle. And on the other triangle we have the same thing, the angle, the side, and the angle. So let's go ahead and write our congruency statement and say that we have congruent triangles by angle, side, angle. So triangle, let's start with the single mark, R, and then let's go to P, and then A is congruent to triangle. I'm going to start with R again, single mark, and then go to the double mark, N, and then the unmarked L. So RPA is congruent to RNL, and we got that by angle, side, angle. And finally, we want to get these two sides. And we can see here that if we look at the first or the second 2 letters, P and A, and the second 2 letters, N and L, we can get that from CPCTC. Congruent parts of congruent triangles are congruent, including this segment. So we can say PA equals NL. And that was exactly what we were trying to prove. So we are done.